Hey, what's up, everybody? Isaac here with Civil Engineering Academy. Excited to share another awesome podcast episode with you. Today, we're going to do something a little bit different. Many people are studying or preparing for their FE and PE exam, and I thought it would be fun to go over some conceptual type problems together and kind of walk through them. We won't go through a ton of them, but I think it would be good to hear these if you're listening to the podcast and see these if you're watching this on YouTube. But I'll do my best to also describe the problem itself. But helpful to just walk through these problems, at least a few of them, to give your mind the perspective that it should have when going in and solving these type of problems when you're dealing with conceptual type problems. The conceptual type problems that come up on the exams, they always ask quite a few of them, and people are always surprised about how many they actually ask. And so typically, the PE exam is still broken up into kind of an AM and a PM sort of session. Half your questions are typically in the first half of the exam, and the second half is the other half of the problems. But within those, you're still going to have, 10 to 15 questions of theory in the morning and the afternoon. So still quite a bit of theory that comes up on the exam. So I thought this would be really fun to do and really helpful for people that are going through and studying for the exam. So hopefully this is helpful to you. I know this is very informative. It's been good for me to go through as well, but it's going to be really good for you to wrap your head around and know the things that they could ask you. So anyway, with that, we're going to go through a few examples, and it's going to be coming up right after this. See ya. All right, so let's get right into it today. We're going to talk about some theory or conceptual problems. Typically, that includes some short answer questions as well. And today, what I want to do is go through what are our 20 bonus theory questions, which are actually a part of our course at the Ultimate Civil PE Review course. If you go to civilpereviewcourse.com, you can grab these, or if you go to civilengineeringacademy.com, we sell these on there, and you can take advantage of that and grab these. We're not going to go through all of them, but it would be helpful to go through some of them so you have a better idea and feel for what they could throw at you on the exam. These are meant to have the same look and feel as a real exam. These are definitely not going to be probably what's going to be on the exam, but who knows? Stuff can come up, and maybe you might have one or two that are very similar. So anyway, that's what this is part of. So it'd be fun to walk through. So the first question that I have on this these bonus theory questions is really a short answer question dealing with wastewater, because sometimes those come up, and really those are conversion type problems. So the question states, what will the wastewater plant size in pounds per day be for a city with 10,000 people in order to handle 500 milligrams per liter of solids? And you're going to use an average volume per person per day to be 110 gallons per day. Okay, so the question is, how are we going to solve this? So we have to solve for what's called the feed rate. And in order to do that, really, we just need to get our units to work out. So if we're sizing a wastewater plant and the units come out to be pounds per day, and we know we have 10,000 people, if we multiply 10,000 people, multiply that by 110 gallons per person day, and you multiply that by 500 milligrams per liter, you have to also use a nice conversion as part of this. And that conversion is that there is 8.345 pounds per mega or million gallons and 1 milligram per liter. And those conversions are in the new handbook. They are also in the front cover of the Civil Engineering Reference Manual. So that's something you just have to remind yourself that you're going to have to look up some conversion factors sometimes when you're solving these short answer problems. So if you work that out, you multiply all those things together because you're really trying to work out the units here, and you'll end up with an answer of about 4,500 pounds per day, which is what they're looking for. And that's the closest answer. So that was a real quick short answer one. And that's typically what, what you might see for a wastewater treatment plant type of problem. All right, the next one has to do with water resources. And the question states, which of the following cross sections is the most efficient for an open channel design? And the options for those listening are an upside down triangle, a square, a circle, and a half circle. And so you're left to think about what is the most efficient cross section for open channel design. And if you're looking at those shapes, you might be wondering, how in the world am I going to solve for that? Well, if you are deep into your studies, you'll end up figuring out the why behind some things. And one of the things you have to really consider in looking at what is most efficient for an open channel design is what's called the wetted perimeter. And the wetted perimeter is how much of the surface is actually touching a surface of water. And that is what your wetted perimeter is. So if it's running, all the way full in a circle, like a culvert, it would be that whole thing. The whole circle would be the wetted perimeter, right? Everything on the outside there touching the water. But in this case, what is most efficient? And the answer for that is that a semicircular cross section. And the reason for that is because that has the smallest wetted perimeter, because of that, it has the highest efficiency. Because of the increased cost to construct due to labor and formwork, it is not typically really built in the real world, but it is the most efficient because it does have the smallest wetted perimeter, meaning it is the most efficient. So that's something to really brush up on if you are studying problems dealing with water resources. Make sure you understand what the wetted perimeter is. Another good one is to know what the hydraulic radius is as well. So keep that in mind. All right, let's look at another one. This is number 3. When is the hydraulic load the greatest on concrete formwork? And your answers are A, during pouring of the concrete, B, after the concrete cures, C, just after pouring, or D, 3 hours after pouring. So think about that for a minute. When is the hydraulic load the greatest on concrete formwork? Is it during pouring, after the concrete cures, just after pouring, or 3 hours after pouring? So if you're thinking about that, think about what the hydraulic load is. Now, the answer to this is that it is just after pouring that increases, or that your hydraulic load is the greatest. It is the highest hydraulic load always happens immediately after pouring. As concrete begins to set, it actually supports itself and reduces the force on the formwork. So loading during pouring doesn't have the volume behind it to cause the greatest load. It is immediately after pouring that causes the greatest loading. So these are questions, and what I'm trying to point out to you is that sometimes it just takes really good engineering judgment to think about these. Sometimes you're just not going to study a lot of this material as you're going through practice problems. So it's important to understand that you're going to have to use really good engineering judgment as you're going through problems, and really understanding the conceptual or theory type problems as you get hit with them. So something to keep in mind. All right, number 4, let's look at this one. What is the following mode called? And what it is this comes from project management. It shows a activity on node type of diagram, or I guess we're supposed to figure that out. So we're not quite sure what we're looking at, but it shows a start date or start block. It shows an arrow pointing to an activity A. That activity A branches into 2 other activities, B and C, and then those also head to other ones. So you have predecessors and successors to these activities. So from B, it goes to D, and from C, it points to D and E, and then from D, it points to F, and E points to F, and then from F, it points to the end of this schedule, or these activities, So it says, what is the following mode called? Is it called a PERT, PERT? Is it an activity on branch? Is it a CPM model? Or is it an on-node, activity on-node type of model? So this is a great question for a construction type of theory question. So you have to really understand how these diagrams, how these are drawn out. So because in this case, nodes are used to represent activities. So basically we have these nodes that represent activities, A, B, C, D, E, F. This is an activity on node model. The PERT model, which is the program evaluation and review technique, is a different way to find activity durations using statistics. And an activity on branch has arcs that represent activities, which this isn't really showing. So a CPM isn't correct either because an activity on node is used to make a CPM model. So again, you need to brush up on your project management for scheduling, and you can really get a feel for how these are drawn out and the diagrams that they have. So good question. What's the following mode called with some activities drawn out there? So good stuff. All right, let's jump to number 5, which states which test is the best for quickly determining field compaction. Is it a nuclear gauge? Is it an SPT test? Is it a CPT test? Or is it a dilatometer? So cue the Jeopardy music, huh? So hopefully, as I'm going through these, maybe you're taking a pause and you're thinking about the answer to these as we go through them, because that's the point. But these are kind of things that you will come to understand again as you work more problems, understand the different test methods, and reason these questions out using your best engineering judgment. So again, which test is the best for quickly determining field compaction? Is it nuclear gauge, SPT, CPT, or dilatometer? And the answer to this is the nuclear density gauge. That is the fastest way to determine field compaction. I've seen people travel with these in the airport. You got to have all sorts of clearances and stuff because it does have some sort of nuclear material there. And basically, it's a probe with radioactive material in it, and it's inserted into a hole punched into the compacted soil. And the rate of radiation penetration is measured to give wet density, and the dry density is calculated. And the water content is given as well. So it is the quickest way to determine field compaction. So another good one. All right, let's jump to number 6. During a seismic event, when liquefaction occurs, the shear strength comes from what? Or the shear strength becomes what? Sorry, let's read that again. During a seismic event, when liquefaction occurs, the shear strength becomes larger, A, B is smaller, C is 0, or D remains the same. So think about a seismic event. Think about what liquefaction is. When there's sand, it kind of becomes a liquid. So what happens to that shear strength? Larger, smaller, 0, remains the same. So this one you should be able to reason out, hopefully. And the answer to this one is 0. Okay, so during a seismic event, liquefaction can occur in saturated cohesionless sands, causing the shear strength of the soil to become 0 and liquefying, becoming like water, right? The soil behaves just like water. If you've ever had sand just moist enough, and maybe you put some in your hand and you tap it quite a bit, it behaves just like a liquid. And so that's something important to remember, that when you do have a seismic event and liquefaction's happening, you have 0 shear strength. So good thing to remember. All right, let's check out number 7 together. And the question is, what is the ultimate stress of the specimen? And what they're displaying is a stress strain curve. And you really have to understand how these things are built and what they look like in order to understand where exactly you need to pull an answer for the ultimate stress that it is asking for. So they give a short little graph and they give some values here, and they could potentially mix up what they want to ask on here including like where your yield point is, where a fracture point is, etc. So you have to become very familiar on the exam dealing with stress and strain curves, because they could ask a lot of different things related to those. So in this example, we've got a stress and strain curve. Stress is on the vertical, strain is on the horizontal, and it's looking like two mountains, I guess. I don't know. But you basically have a nice curve that goes up and then it rolls down. So the answers here are 400, 500, 700, and 1,000. So in this case, this is again is simply a stress versus strain curve that we're looking at, and it's meant to test how we make an interpretation of this. So the ultimate stress here is located at 1,000 KSI. There are other important values that we definitely need to become familiar with, but the ultimate stress of this specimen is this highest point up here, which is 1,000 as it's listed in the graph. So again, if you're listening to this on audio, you'll want to make sure that you become very familiar with stress strain diagrams and understanding all the things that they could ask you as part of that. Good one. All right, next theory question says, what is determined by the impact test? What is the impact test? So if you remember what an impact test is, it measures the energy in order to fracture a sample. So your answer selections here, it's asking what is determined by the impact test. A is toughness, B is hardness, C is ultimate strength, and D is yield strength. And again, that's related to, our stress strain stuff, but it is dealing with materials. A very good question. What's determined by the impact test? So if you recall, the impact test measures the energy to fracture a sample, which is its toughness. So ding, 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 it is a toughness in this one. So that is a materials type question. You'll want to brush up on stuff about that. Number 9, regarding the level of service, which of the following statements is correct? So now we're switching to transportation a little bit. LOS stands for level of service. And the question is, which of the following statements is correct about level of service? A, level of service remains the same throughout the day. B, there are 6 levels of service. C, level F represents unimpeded flow. Or D, economic considerations favor low traffic volumes. Now, if you're studying from the SERM, you're going to be able to find some of this information. I have not dived into the new handbook to see if they have this information in there. So you'll have to figure that part out, but it could pop up when you're dealing with level of service when dealing with transportation. So the answers again are that the level of service remains the same throughout the day. B, there are 6 levels of service. C, level F represents unimpeded flow. And D, economic considerations favor low traffic volumes. So I feel like this is something you probably would have to look up or see before, but the answer here is that there are 6 levels of service as part of this answer. And so the answer here is B. The other statements are not true. So there are 6 levels of service is the only answer that is true as part of this. All right, we're going to do a couple more here. Hopefully these are engaging for you. This is fun for me to do, but hopefully it's giving you a perspective of, again, what they can ask you on these tests and something you definitely need to prepare for. So that's the whole point of doing this. I want to make sure you're prepared for the exam. If you need additional preparation, definitely make sure you go check out our resources at civilengineeringacademy.com, where we have exams. We also have a full-blown course to help you on this journey to pass this thing. And, with it being CBT now, we want to make sure you're fully prepared. So let's jump into 3 more, and then we'll go ahead and wrap this up. But this next one, the question states that an engineer has specified sulfate resistive concrete to be used for the construction of a bridge. Which type of concrete should the contractor use? So, you need to understand the types of concrete that can be used during construction. This is one that you will have to experience as you solve problems, right? You need to become familiar with this type of material that they can use, the type of concretes that can be used, and why they would select them in different scenarios. So in this case, let's read it again. An engineer has specified sulfate resistive concrete, that's the key word here, to be used for the construction of a bridge. Which type of concrete should the contractor use? Is it type V concrete, type 5, type 4, type 3, or type 1? And the answer to this question is going to be the type 5, which really provides us a sulfate resistive concrete. So you want to go brush up on the different types, why they're good for different applications, but that's another good one to understand. Let's do 2 more real quick. 16 here.
A few moments later.
All right, let's look at another 2 here, and we'll probably wrap this thing up for us. So the next one says, if in a truss system the number of joints is 8, the number of truss members is 13, and there are 2 reactions, the truss is what? Is it unstable? Is it indeterminate? Is it determinate? Or is it none of the above? This is a great structural question, and you have to know how to determine if in a truss system you have an indeterminate structure, a determinate structure, or if it's unstable. So great question to ask. So again, you've got a truss system with 8 joints. The number of truss members is 13, and there are 2 reactions. So this one you're going to have to dive into probably some reference material. So you're going to go look up what an indeterminate structure is, and you're probably going to find some of these equations. But one of the equations to determine if a truss system is determinate is 2J equals M plus R, where J is equal to your joints, M is equal to your members, and R is equal to your reactions. So you plug in the numbers that are in the problem, see how that works out. So that was 2J equals M plus R. For an indeterminate structure, 2J is less than M plus R, and for an unstable structure, 2J is greater than M plus R. So in this case, we have a J value of 8. That's the number of joints that we have. So 2 times 8 is 16. And does that equal, is it greater or less than M plus R, where M is given as the number of members? That was 13. And reactions were 2, which was, so 13 plus 2 is 15. So in this case, 16 is greater than 15. And so the answer on this one is that this structure is unstable. So unstable was answer A. So good question. You'll need to brush up on your structures and how to determine an indeterminate structure, but something to definitely brush up and keep in mind on this one. All right, let's talk about one last one. And this question says, what type of in-situ test is suitable for sand, silt, clay, and peat? And the answer selections are CPT, SPT, a field vein test, or a pressure meter test. So what type of in-situ test is suitable for sand, silt, clay, and peat? So this one, you're going to have to understand and know different test types, right? For your geotech, what a CPT test is, what an SPT test is, what a filled vein test is, and what a pressure meter test is. And so in this case, for something that is suitable for sand, silt, clay, and peat, a CPT test is what is suitable for all of those. However, it is not suitable for gravel and soil with gravel and cobbles. So if that was thrown in there, that would throw that off. So you have to get a great understanding of what different test types are for each soil situation, or what the geotech tests are in general, in order to solve a problem like this. All right, that's going to wrap that one up. Hopefully this was helpful to you. This was actually really fun for me to do, but hopefully it gives you a flavor of the theory type of questions that they could throw at you, or the conceptual, or these type of questions where you're just going to have to reason and use engineering judgment on these theory kind of questions. So these are always quick to answer, and oftentimes they get engineers, they can get you caught off guard and thrown off. And but make sure you give it your all, give it your best engineering judgment. And I promise that as you work a lot of practice problems, as you study the concepts of those problems, understand the why and the how. What are they using in this equation? Why are they using it? And how things are affected by it. These things will sort of shake out of that. So when it comes to test time, you will be using your best engineering judgment to solve these problems, and you'll be just fine when you get through them. So you can go through them quickly. Hopefully you can get through them very quickly. If you're, a big part of taking the PE or the FE is that there's time management piece to this. So these are kind of nice because you can get through them quickly. But again, they can get you off guard. So anyway, get lots of practice in. Make sure you take your time, build a study schedule, and you'll get there. So if you need help on any of this, if you need additional help, definitely go check us out. If you want a copy of this, or you can get all of the problems that are included with it, go check out civilengineeringacademy.com. There's a tab for breadth exams, and these bonus theory questions are found in there. Or if you're a member of our course, you'll get them as part of that as well. So you can find all of that at civilengineeringacademy.com. But this was really fun to do. So anyway, I hope you're having a great day, and we'll catch you in the next one. Bye.